This is lesson 3.4. Two-step equations. So in this lesson, we're taking what we have done in the last 2 days, and we are taking it up a notch. In your pocket? I don't want to see it again. So it gives us here some steps to solve. And again, I really like these notes. I didn't make them, so I'm not patting myself on the back. I really like these notes in that they give us like a step-by-step, this is how you do the problems. And this is something for you to refer back to. So if you're a step-by-step person, then paying attention to this 1 through 4 is going to be really helpful. Okay, so we're still locating the variable. That hasn't changed. We undo addition and subtraction. Then we undo multiplication and division. And then we check our solution. This seems a little bit crazy, but let's over here to the side remember what our order of operations are. You guys remember doing this the first week with me, PEMDAS? So when we are solving an equation, we're really going in reverse order. So we're going to start with addition and subtraction and undo those. Then we'll move to multiplication, division, and undo those so that we finally get our variable by itself. Okay? So what does this actually look like? Let's take a look at number 1. What's our variable in number 1? P. Okay, so you can either box it or underline it or whatever you want to do so that you can see a reminder to yourself where our variable is. So here is our equation line, right? Do we have any addition or subtraction? Remember I said we're going opposite PEMDAS. Do we have any addition or subtraction happening over here? What's being added or subtracted? Okay, think about the constant. Which constant is by itself? 5, right? So that 5 is the first thing to get rid of. And notice on the left side of the equation over here, 5 is the thing that's furthest away from the variable. You don't need to write all that down. But do you see that 5 is the thing that's furthest away from our variable but on the same side? So that's what you also want to get rid of first. That's another way of thinking about it. Okay? So if 5 is being added, what do we do to get rid of 5? Subtract 5. I heard one person when I should have heard the whole class. Subtract our 5. So this isn't new, right? We've already been doing this. Our 5 is gone. What's still left on the left side of the equation? What do we still have over there? 8p, right? That 8p still exists. And then 77 minus 5 is 72. And now it's a one-step equation that we just spent the last 2 days working on, right? Now what do? Do we have a multiplication or division problem here? Multiplication, right? How do we get rid of that 8?
Divide.
Good. We're going to divide by it. We know that it comes off the P. And so we have 72 divided by 8.
9.
I hear one person say 9.
9.
P equals 9. And then if I asked you to check your solution, how in the past were we checking our solutions? What were we doing? Plugging it in. So I know there's not a ton of space in this box. But if you have 5 plus 8, instead of P, we're putting 9. Right? Isn't that what our P is standing for? Is our 9. Does that equal 77? And oftentimes when students write this, they just write that and they're like, yeah, it works because I plugged it in. No, like you actually have to solve it out. You can't just plug it in and say, yeah, it works. So if we plug this in, we need to take care of 8 times 9 first. What is 8 times 9? It's our 72. What is 5 plus 72? 77. So does 77 equal 77? Yes. So this is actually working it all the way through to show me, yes, it does work out. This isn't just assuming Yeah. 77 equals 77, which I saw happening on the previous lesson. You just plugged in and you're like, yeah. Keith.
Are we going to have to check the solutions on the test review?
So, this is a great question. Should you have to check your solutions on your test? Maybe on one of them I will ask you to. But this is a surefire way to make sure you get an A on this next test. Because you can check every single answer. It's the same as if you're raising your hand asking me to come check it. Because you can plug it back in. And if you got this to be like 70, 5 plus 70 does not make 77. So you know that somewhere you messed up. And you need to go back and fix it. So it's to your benefit to check it every time. I'm not going to force you to do it. But if it were my grade and I wanted to make sure I was getting an A on the test, I would check it every time. Okay? Okay, any questions on number 1 before we go to number 2? All right, number 2. We're going to identify our variable. That's the first thing, which is that in there. And if you need to divide your equation in half, so you know which your left side and right side is. Okay. So on the left side of the equation, do I have an addition or subtraction? Remember, we're doing reverse PEMDAS. Do you have an addition or subtraction? Yes. We have an addition. So to get rid of that 2, Jose, what am I going to need to do?
Subtract it.
Okay. But whatever we do to one side, we have to do to the other side. So on the left side, I am left with negative n. And 7 minus 2 is 5. Is this all the way solved? Is n completely by itself? No, we talked yesterday that when there's a negative sign, that's really a what? A negative 1. And we have to move it off of there. So if you look back on the previous example, we're at this point now, where we have 8p equals 72. What do we do to get that 8 off of there? Divided it. So how are we going to get that negative 1 off there? Divide by negative 1. To both sides. A positive 5 divided by a negative 1.
It's a negative 5.
Remember this thing? And you cover up positive and negative, leaves you with a negative. So it should be a negative 5. Again, if you want to check it, you have your negative 5. Right, you already have that negative sign out there. And then you're plugging in a negative 5. Plus 2, does that equal 7? Don't just say yes from this point. You need to actually solve it out. Negative makes what? So then you have 5 plus 2. Does that equal 7? 7 does equal 7. Check. All right, I'd like for you to try number 3. So we've done 2 examples. I want you to try number 3 the way we've been doing it. Okay? Try number 3 for me. Find your variable. Divide your equation in half if you need to. All right, number 3. Ashley, what'd you do first on number 3? Okay, so let's do it together. Here's your x. What are you going to move off first? Which one, the first 6 or the second 6? Okay, and it's a positive 6, right, because you're looking at the sign in front of it. So how would you move that 6 off there? Okay. I'm going to subtract 6. Subtract 6. So we have negative 6x equals 102. Okay, Blake, what do we do next to get x by itself? What do we need to move off of there, Blake? What?
You just divide by 6.
Okay, divide. We need to move this 6 off, so we're going to divide by not just 6, but a negative 6. So if it's negative, you're going to take the negative with it. And then you don't need your calculator because you have your times sheet. 102 divided by negative 6. It's a negative 17. Negative 17 here. Any questions on 3? That one might have been a little bit tricky, I think, Ashley, because you weren't sure what the sign was, maybe in front of that first 6, that there was actually that positive sign right there in front. If we wanted to check this, I could have 6 minus 6 times negative 17. Does that equal 108? Well, what's a negative times a negative here? Positive, right? So that's 6 plus 102. Does that equal 108? 108 does equal 108. Okay. All right, number 4. It's not as hard as you think. On number 4, locate your variable. Look at your two sides of the equation. Remember, you're doing reverse PEMDAS. Every time you're doing reverse PEMDAS. So do you have any addition or subtraction?
Yes.
We have addition, which means how do we undo it? Subtract. Okay? So let's subtract our 2 over. Can you take that out until I'm done teaching, please? So on the left side, I'm just left with m over 3. What is 0 minus 2? If you don't have anything to start with, you're going to have negative 2. Okay? So now, if we want to get rid of this 3, it's being divided, right? And so what's the opposite of division? Multiplication. So we're going to multiply each side by 3. And remember, we did that yesterday. They cancel, but whatever you do to one side, you have to do to the other side. So we're going to multiply by 3. So I'm left with m equals, what is negative 2 times 3? Negative 6. Awesome. How you feeling about that? Crickets. Perfect. Okay. Let's try number 6. Let's hop down and do number 6. We're on page 11, Destiny. Remember, you're doing opposite PEMDAS, so locate your variable first. Figure out what's over there on that side that needs to be gotten rid of. So we have our x over here. We're trying to get it by itself. So if I have any addition and subtraction over there, that's what I need to take care of first. David, what did you do first?
I minus 10 by 10 on the right side, then minus 10 on the left side.
Perfect.
Then got 20 on the left side.
Okay. I would agree with that. We're taking the negative 10 off, or we're taking the 10 off of the right side of the equation. And now I have negative 10 still attached to the x. Remember, when we're going reverse PEMDAS, I'm looking now for this step. Do I have multiplication or division there? Okay, Cheyenne, what should we do? Divide by 10 or negative 10?
Negative
10. Okay. Divide by negative 10 on each side. $20 divided by a negative 10. We get a negative 2. Questions? Okay, let's try number 8. It's just like number 4. I want you to try number 8 on your own. Number 8, just like number 4. Your question is short. Try number 8. It's just like number 4. Not 7. Number 8. Pay attention to what you're doing. Number 8, please, not number 7. Find your variable. First thing we needed to do was get rid of 9, and so we add it to both sides. So we have b over 3 equals 6. Okay? b over 3 equals 6. That's what happens when we add negative 3 plus 9. They're opposite signs, so we really subtract. Now, 3 is being divided, right? And so if we're doing reverse PEMDAS, remember, now I have a multiplication division problem. So if 3 is being divided, how do I get rid of it? Multiply by 3? You could do 3 over 1. If you put it over 1, is it going to change anything? No. And then 6 times 3 is 18. Did anyone have 18 down?
Yeah.
A few of us getting there? Okay. Let's try number 7. Go as far as you can, please. What are we going to move off first? Mackenzie, what are you going to move off first? The positive 8, and so what are you going to do with it? Subtract 8. And 3 minus 8? What'd you say, Taylor? Negative 5. Okay, Keith, do you remember what we do? Coming back to you because we talked about this earlier today. When we have 5/3 there?
So you multiply 5 by 3, 3 by 5, and it cancels each other out.
So you multiply it by, 3 over 5, by the opposite. Okay?
How do you check your work on this one?
It's a great question. I'll show you in a minute. So we multiply by the reciprocal, which cancels these out. And if I'm going to multiply negative 5 by 3 over 5, 5 is really over 1. And when we multiply fractions, we multiply how? Straight across. So negative 15 over 5. What is negative 15 divided by 5? Negative 3. I understand you don't love fractions, but that doesn't mean we're going to always avoid them. Okay, it doesn't mean I'm going to give you 20 fraction problems, but it also doesn't mean we're going to avoid them. So Keith asked, how would you check this? So we have 5/3 times our k value, which is 3. Thank you. Plus, what was it, 8? equals 3. So Keith, if I were to check this, I could put my 3 over 1, and I would multiply here, negative 15 over 3. What is negative 15 over 3? Negative 5. Negative 5 plus 8, opposite sign, subtract. I'm not asking you to do that right now, okay? But that's how you would check it. You're still multiplying your fractions straight across. All right, let's flip to the next page because we're going to do the same thing. They're going to make it look a little different for us, okay? Okay, we still are having two-step equations, but now it looks a little bit weird because we have the entire thing is being divided by something. We have to take care of that first before we can do anything else. Oh my goodness sakes. Look at your variable, which is that x there. But we can't do anything else to the problem because this whole thing is being divided by 3. So this 3 is like taking everything hostage. We can't do anything else until we get rid of that 3. And so that 3 is being divided. Even though it's under 2 different numbers, it's still being divided. And so what's the opposite of division? What undoes division? Multiplication. So in order to get rid of that 3 on the bottom, because it's holding the x and the 8 hostage, we're going to multiply the entire thing by 3. When I do that, it cancels the 3 out on the bottom. It does not distribute. It cancels the 3 out on the bottom. And then whatever you do on one side, you have to do on the other side. So we're going to multiply the other side by 3. On the left side, I am left with x plus 8. And on the right side, I'm left with what? 9. And now you know how to solve this. Yes, Mackenzie? Okay. We had to get rid of this 3 on the bottom. And by doing that, you're multiplying the entire thing by 3, kind of 3 over 1. Look up there at the board. Like 3 over 1. So when you have 3 over 1 times something over 3, those cancel. Okay? How to get rid of that 8, Kiesia? Thank you, Kiesia. What'd you say? Subtract, right? So we're going to subtract 8 from each side. 9 minus 8, 1.
Could you just leave it as x if it equals 1?
You mean, can you just leave it like this?
Yeah.
No, because you're not telling me what is x equal. What number is x?
I thought x always equals 1.
X does not always equal 1. The coefficient in front is always 1. Different things. Okay, so if we think about number 9, we would check the same way. We would plug our 1 into the top. 1 plus 8 is 9. 9 divided by 3 is 3. So on number 10.
Multiply the whole thing by 3.
Nope. On number 10, we're going to multiply the entire thing by 4.
That's what I said.
You said 3, didn't you? So we're going to multiply the entire thing by 4. And it's really 4 over 1. But it cancels here. That's the important thing to know, that it cancels. So don't try to distribute that 4 here and here. That's incorrect. It cancels, leaving you with just r plus 4. But remember in math, whatever you do to one side, you have to do to the other side. 4 times 4 is 16. How are we going to get 4 by itself? Subtract it. And we get r to be 12. Any questions, guys? You got the hang of it. Awesome. Okay, try number 11. It feels good when you get the hang of it, doesn't it? Yeah, try number 11. Go ahead and pause the video. So we're going to multiply the whole thing by 6. Cancels. Got rid of our fraction. Gonna multiply the other side by 6. I get 12 equals 5 plus m. How do I get this 5 off of here? Subtract it over. Man, you guys are... It's Thursday. M equals 7. Raise your hand if you have 7. You guys are killing it. Okay. For time's sake, we're not going to do number 12. You guys are ready to rock and roll. We're going to skip the word problems for today. I'd like you to go to page 14. And I want you to do 1 through 15 odd on page 14. That's homework 19. 1 through 15 odd. But I'd also like to show you to talk about homework 18. So go back a page to homework 18. I want to show you how this one is done. It's actually kind of cool. 18, that relay race thing. Okay, on this relay race thing, the answer you get here is going to be what goes in the blank here. Okay? So the answer you get in the first box is going to be what goes in the box here. So let's do the first one together. 9x plus 13 equals negative 5. So remember, here's our variable. What are we going to get rid of first over here?
Subtract 13.
We're going to get rid of that 13. So Taylor says we got to get rid of that 13. So we're going to subtract 13. Negative 5 and negative 13, when they're the same signs, I'm really adding them together. 5 and 13 is 18, but it's a negative 18. How do we get x by itself? Divide by 9. And we get x to be a negative 2, which means this is a negative 2. Right here. That becomes a negative 2. Okay? All right, so you need to do homework 18 and homework 19, 1 through 15 odd.